All right, this is number 2 on page 67 in the Exeter Math 1. We're also using it to study for quadratics in CP Math 2. So I'm looking at A here, and we need to do two things. We need to find the vertex and write an equation for the axis of symmetry. So, and it says sketch a graph. So one thing I do want to bring up here is we can factor this, factor A3 out. And when you factor out a 3, you get three parentheses x squared plus 2. Now, that might help. On this one, it doesn't help a ton. But if I graph this, sketch a quick graph of this, I know that this is a shift up of 6. And then it's just stretched out by 3. So it looks something like that. Which means that my vertex here, and you could use a calculator for this, that would have been fine. Your vertex here is at 0, 6. And the axis of symmetry runs right through that x point of the vertex, which would be x equals 0. So your vertex is 0, 6, and your axis of symmetry is x equals 0. Now, if you're going to do this algebraically, what we would do is we use this formula, the opposite of b over 2a. And what that does is it helps us find the x-coordinate of the vertex. So that gives us that 0 there. So b is our x term. So actually, out of all these numbers, the only one that even has a b is this one right here. Check that. This one has one, d has one, and b hasn't. So this is our x term. Or sorry, b is our x term. So a does not have an x term. There's no x. This is a. A is 3. B is not there. C is 6. So you'd have equals 0 over 2 times 3, which is 0. That is our x-coordinate of our vertex, right there. You can substitute that in now to get your y-coordinate. Sub that 0 in for x. So 0 squared is 0, times 3 is 0, plus 6 is 6. So there's your y-coordinate, which was right here. So your vertex is 0, 6, and your axis of symmetry is always x equals whatever your x-coordinate is. There's A. Okay, now for B. The first thing I'll do is factor y equals, this time I factor an x out. I get x plus 6. Now what this tells me is these two are where my x-intercepts are. So I set each of these equal to 0, x equals 0, and x plus 6 equals 0. X equals negative 6. So now if I graph this, I know this crosses at 0, and then x equals negative 6. 1, 2, 3, 4, 5, 6. So it's going to look something like that. Not a very symmetrical picture, but it should be symmetrical. So the way I look at it is the vertex, or the axis of symmetry, I should say, would go right through the middle here. And what's in the middle of 0 and 6? -3. So x equals -3 would be your axis of symmetry. And I substitute that into my equation. Y equals -3 squared plus 6 times -3. Y equals 9 minus 18, which is -9. So that means that this vertex here would be at -3 comma -9. That is your vertex. Oops, we put parentheses around it. So that's the first way. Another way you could do it is to use the -b, or opposite b, over 2a. B now is 6. So -6 over 2 times, and a is the coefficient on the x squared, which is just 1. So that gives our -3. That -3 gives us both the axis of symmetry and what we plug in here and here. So realistically, you need to either go graphically or opposite b over 2a to get this axis of symmetry there. And then that substitutes in to our function to find our other point of our vertex, the y-coordinate. Okay, we're looking at C. Let's do this one algebraically first and then graphically. So algebraically, I want to find the axis of symmetry, so I would go -b over 2a. That is, well, let's see, the b here, there isn't one, because there's no x term. See, we had a 6 here, but there's no x term here. So that would be -0 over 2 times, and realistically our a here is -4, but it doesn't really matter because 0 over anything is 0. So our axis of symmetry is x equals 0. And then we plug that back in to y equals 64 minus 4 times 0 squared. So our vertex is at, let's see, 64, that's 0 squared is 0, times 4 is 0, so that would equal 64. So our vertex is at 0, comma 64. All right, and let's try D. Okay, on D, I'm going to do it algebraically first and then show you the way you would do it graphically. But algebraically, you go -b over 2a. So negative, b is -2, right there. A is 1. So -2 over 2 times 1. So it's -2 over 2, which is -1, and then the negative in front makes it a +1. So our axis of symmetry is x equals 1. Now we substitute that back in. Y equals 1 squared minus 2 times 1 minus 8, which is 1 minus 2, -1 minus 8 is -9. And again, you could use a calculator for that. So my vertex is at 1, comma, -9. Again, the axis of symmetry and the x-coordinate should be the same. Those right there should be the same. Now, if we were doing this graphically, what I would have done, so you have y equals x squared minus 2x minus 8. If you remember how to factor, double bubble, and we have 4 times 2 is 8. And it has to be a negative 2 in the middle, so we should have that right there. Double check here, negative 4x plus 2x is negative 2x, which means that our x-intercepts are at negative 2 because of this, and positive 4. It's always the opposites here. So if I graph that, negative 2, positive 4, our graph's going to look something like this. Our axis of symmetry is going to be right in the middle, which is at 1. And then you plug that back in, substitute it back into our function to get our y coordinate.